following represent the Maxwell's distribution curve for an ideal gas at two temperatures, T1 and T2. Which of the following options are true? Total area under the two curves is independent of the moles of the gas. Now we know that the total area under the curves is equal to the total number of molecules, and the number of molecules, right, their relation with the number of moles is equal to the number of moles times the Avogadro's number. Therefore, the number of molecules, if we call them as capital N, the number of moles would be N divided by Na, right? So, the total area is not independent of the number of moles. It would depend upon the number of moles of the gas. U most probable decreases as temperature increases. Now, U most probable is the speed that most fraction of the sample contains. So this is the highest fraction, okay, for temperature T1, and this is the highest fraction for temperature T2. The most probable velocity for T1 is 0.1 and this 0.2 is the most probable velocity for T2. So therefore, as the temperature decreases, that is, we go from T2 to T1, here we can very well see that T2 is greater than T1. As we move from T2 to T1, the most probable speed does decrease. So statement B is correct. Statement C is T1 is greater than T2 and hence higher the temperature, sharper the curve. No. Actually, T2 is greater than T1. Why? Because as temperature increases, the most probable velocity, which is given by root 2 RT divided by capital N, which implies that the most probable velocity is proportional to the temperature. So higher the temperature, higher the most probable velocity. And since at T2, the V most probable is further away on the x-axis, that is, it is higher. So T2 is higher than T1. Okay, so statement C is incorrect. The fraction of molecules having speed equals to U most probable decreases as the temperature increases. Now, we know that temperature T2 is higher than T1. So, when we move from T1 to T2, the fraction goes from F1 to F2. And we can see that F2 is smaller than F1, right? So, the fraction definitely decreases as the temperature increases. So, statement B is also correct. So, the correct options are option B and option D.